Gentlemen and ladies, welcome to another video. This one really is all about Mercury Rectifiers, which really date back almost like 80 years or so. And today we're going to have a look at one that has been in the box forever. Well, 60 years. So we're going to take it out of the box for the first time and we're going to see if we can get it to work. But first we're going to have a little look at various different diodes and rectifiers, just so you know where we're going with this video. It's quite long. Might be about 20 minutes, half an hour, so use the little skippy button and get to your best bit that you're looking for. So let's get straight on with it. These are your typical silicon diodes, very low power. The one on the left there is slightly higher voltage, and they all do the same job. They act like a valve and it lets current flow in one direction only. This one's a 100 kV diode. These diodes can handle 6000 amp in a pulse, or maybe 500 amps continuous. This is a controlled rectifier, and we've got gates on this one where we can control our output. This rectifier set can do 1,000,000 watts, and this one can do 1,000,000 volts. So they come in all sorts of shapes and sizes, but today we're going to look at something a bit more interesting, the way they did it in the old days, using mercury rather than silicon. This is what things used to be like before silicon. So this one is a tiny one out of a battery charger, and you tilt that to get it activated. Single phase. This one is a 3-phase, and the one in the middle, 6-phase. This one's 3-phase with grid control, and we've got an excitron sitting there. So the way these work is really simple. There's the circuit for the single-phase rectifier. Very simple. Centre tap on the transformer is the negative. This one's the 3-phase one. Star point on the transformer, again negative. And this one's the 6-phase arrangement. There is a 12-phase arrangement as well. This looks really complicated, but it's not. It just has the pilot in situ, and it has the excitation and all the chokes, coils and solenoids and everything else to run it. This one's sitting here. We're going to power up so you can see it. Remarkably simple the way they work. There's a big pool of mercury in the bottom there. That little rod dips in the mercury to trigger off a few atoms. Then we normally keep it alive using these two pilots. So then you can turn the main anodes on and off as and when you need it. You don't have to go through the restriking process. But on today's later experiment, I'm going to attempt it just from excitation to main anodes. I'm not going to worry about pilots and having all the bits and pieces on when it's not necessary. The way these rectify is once we've got excitation and we've got voltage on the anodes will fire alternately because it's a split phase transformer, and it will only flow in a forward current. There's no reverse current. So the DC comes out the bottom and we end up with 100 Hz ripple on a 50 Hz system, which we are in the UK. That's how the thing actually rectifies and changes AC into DC, simply by using the mercury vapour as a block and a valve. It would only allow, as I say, that current flow to go in a single direction through the mercury vapour. So these really are just two diodes. There's one diode, there's another diode. That's all it is. Work of art. Right, okay, to start this thing you'd have an electromagnet on that, just to dip in there to create a little tiny little spark, and then there's a little shot there with just the pilot on. And now we've got main anodes. In this box is the rectifier itself, untouched after all those years. So I think we need to drag it into the other room and open it up very carefully indeed. That is ancient, and it's very rare to actually see one of these in the box. So this is probably the first on YouTube where you're going to see it from scratch, from opening it to attempting to power the thing up. Let's drag it next door and have a look. I think it's time to lift the lid on it and see what's inside it. Ah, 50 years of dust. Let's have a look. That is dusty. I think we need to clean it and remove it and have a good look. That's tasty, isn't it? So, a little bit of cloth, a little bit of spray. I'm going to clean the bottom. And the dust will stick to the cloth, hopefully. Dispose of this. Repeat. Until it's clean. I think we should remove it. Right, let's have a look. What I don't want to do is tread on the slippery bags and go flying with it. But luckily I've handled these before, so we shouldn't have too much of an issue. We will see what happens, he says. Got to undo all these straps. First time in 50 years. They're a little bit old. Right, we're almost there. We are ready for a lift out. You ready, boys? Here we go. Looking quite good, but very dirty. All that juicy mercury there, look. Let's clean it up a bit, it's covered in it. Well, I've got the bottom end reasonably clean. Now what I want to do is try and offer it up on that stand so I can clean up the rest of it. But the mercury doesn't look too bad in there. That's the little exciter. So we need to tip it up and get mercury in this reservoir. It's risky. Slowly, slowly. Because the mercury's that heavy, you can actually knock the bottom out. We wouldn't really want to do that. So bit by bit. There she is. Let's see what that sits like on this. That bit of wood there stops it coming forward, and this one stops it going back. So the whole thing can't go anywhere. See that mercury sloshing around? I think we should power it up. So the little bit in the bottom there is the exciter, and we get that to dip in the mercury there's a little magnetic thing there. Normally a solenoid goes on that, but if I put this magnet on it, that will pull that into the mercury like this, look, and that sets it off. So that's what gets a few mercury atoms flying around, and once that happens, obviously now we'll start conducting on these anodes back to the transformer. So to start it, it's quite straightforward. 240 volts, 38 volts, something like that, 30, 38, into a rectifier, through these resistors, through this choke, which gives a nice kickback, and that's all what runs it. That's my phone, I apologise. So I'm plugging this circuit in. Now we're going to start it. Excitation. Now main power from this lot. There we go. Excitation off. That's the transformer there making some noise. So the power supply side is all this nonsense. As I say, it's an 11 kV split phase transformer, which the National Grid would normally use, but it's handy because it's split phase. That down the bottom is the output. These two would be the anodes going in. And the primary of this transformer is only being fed by this one. It's 100 amps. So with a pile of transformers. Sounds nice though, doesn't it? But more importantly, doesn't that look nice? I could watch that all day. Better than TV, isn't it? You've got to be mad to have one of these in your living room. Don't get many shots like that. Normally these things are all behind a screen and you can't even get close to it. But there's me touching it. Like a giant plasma ball. It's good. Might be better with the lights off though, really. Don't know. That's the transformer rattling. There's a bit of magnetic field over there. There's the box it came in. that nice, look. What's this? Just rattling. What's this? Whole wire shaking. It's quite hot. Gives you an idea of what's going through it, doesn't it, eh? It's not complaining though. Oh, I do like that. You bored with it yet? Alright, better wind it down then. So if I reduce the power, still rectifying, yeah, it drops out. Good. You can see the condense in there. That's normal. At least it ain't gone black. We'll have one more little go on this. You can see, just in case the bottom comes off, I might be able to contain a bit of mercury. But my body stand is doing the job. It's a very temporary thing. As you can see, that one stops it coming forward, and the one up here stops it going back. But there's still some movement, which is nice. So as I say, it can't come forward because of that one at the back, and it can't go back. So whole thing reasonably stable. It's not going anywhere. It's all that mercury sloshing around. Wouldn't really want to have a bit of a spill in here. So you can see a bit of condense on it because it's been running. Eventually that clears when all that, that's the cat, when all that condensed mercury falls back into that pore. Oh look, the cat's coming to investigate. Again, there's our little exciter, what dips in there, look. Activated by a magnet instead of a solenoid. And then give it some. No X-rays, a little bit of UV though. Third anode, not in use. Yeah, I could watch that all day. It's going good. Shut it down, shall we? Reducing and off. Here it is, back in the box, nice and secure, upside down as it should be. That's how we transport them. It's a good idea. Now we can see the anodes. Let's see if we can get on this and have a look at it. There it is. Anodes, 3 of those. These are the pilots. And the exciter. Upside down, of course. Oh well. It lives another day. Put the lid on it, store it for another 50 years, I guess. It seems quite a shame to put this away back in the box, but before I pack it away forever and cover it in blankets, I will clean these up and get any corrosion off, and very carefully without twisting these, and I'll coat that in some oil to prevent some future moisture ingress. And these anodes, I think I'll be kind and I'll repaint the Aquadag on there. And that will be nice, that will look good then, because some of this has come off. But it's nice because we can actually see the emitter in there. but I'll repaint it. The job of that, it stops the mains hum coming through on other devices nearby. It helps trigger the current flow because it's conductive, and obviously it blocks a bit of UV. It's almost like the stuff on the back of TV tubes, the old CRTs. It is conductive. So that's it. Well, we finally made it to the end of the video. I do hope you enjoyed it, and I will see you very soon on the next one. Shall we have the outro music? Do you remember that old outro? Shall we have it? Go on then. Take it away.